Hi. Now, in this tutorial, what I want to do is show you how we go about solving differential equations by a method called separating the variables. But before I do that, I want to quickly just take this equation and I want to differentiate it with respect to x. I'll just write diff with respect to x for short. Okay. Now, I'm assuming that you're familiar with implicit differentiation. If not, you can always see tutorials on my website, or if you're viewing this on my website at the moment, you should see a link to this implicit differentiation above this video. So if we differentiate this with respect to x, the first term would go to 10x. If we differentiate minus y cubed with respect to x, we get minus 3y squared dy by dx. Okay, and then that's going to equal, and if we differentiate 4y with respect to x, we get 4 dy by dx. And then if we differentiate x with respect to x, we get 1, and if we differentiate the constant here 4 with respect to x, it's just 0. So all we need to do now is just rearrange this for dy by dx, and I'm going to subtract 1 from both sides, so I get 10x minus 1, and I'm going to add 3y squared dy by dx to both sides and factorize at the same time, so I just get the 4 plus the 3y squared, and then that will be dy by dx. So I can now rearrange this and I get that dy by dx equals, and if I divide both sides by 4 plus 3y squared, I get it equals 10x minus 1 all divided by 4 plus 3y squared. Now I did this just to show you what we mean by a differential equation. When we get equations like this and we're asked to solve them, then we've got to take this back to this stage, or something equivalent to it. And this will be what we mean then by solving a differential equation. So let's just come down here, and what we'll do is we'll take a typical question then, which would be to solve this differential equation dy by dx equals 10x minus 1 all divided by 4 plus 3y squared. Now if we had to solve a differential equation like this, then what we do is we do it by a method called separating the variables. That is, we put all the y's on one side and all the x's on the other side of the equal sign. So we would multiply both sides by 4 plus 3y squared, and we would therefore have 4 plus 3y squared dy by dx equals 10x minus 1. Now for the next stage, it's as if we would multiply both sides by dx. We're not really doing that strictly, but if we did, then it would be 10x minus 1 times the dx. So we'd therefore have 4 plus 3y squared dy equals 10x minus 1, and that's with a dx there. But what we do to both sides is we integrate both sides. And you should try and do this in one stage, from this line here straight to this stage here. Or you might be able to go from here straight to this stage in one go. But essentially what we do is we get all the y's on one side of the equals and all the x's on the other side of the equals, and integrate both sides. It's called separating the variables then, and you can see why. Now all we need to do is integrate this side with respect to y, and if we do that, if we integrate 4 with respect to y, we get 4y. Integrate 3y squared with respect to y, you get 3y cubed over 3, which is really just y cubed. and you're going to have a constant of integration. Let's call it plus, say, C1. Now we come to the other side here and we integrate 10x with respect to x. That's going to be 10x squared over 2 or 5x squared. Okay? Integrate the 1 with respect to x, that's going to be minus x. And then we're going to have a constant of integration here. Let's call it, say, C2. Now when you get something like this, what we tend to do is leave out one of the constants. I'll explain why. You'll quite often see people write this as 4y plus y cubed. They'd have come off this stage here, left out the constant, gone to this integral here and got 5x squared minus x, and would have just written, say, plus c. Why did they do that? Well, essentially they've gone through this stage. They've seen that they've had a constant here and a constant here, and when you do C2 minus C1, if you subtract C1 from both sides, you get C2 minus C1. A constant minus another constant gives you a constant. So this stage will often be avoided. Some people will just write 4y plus y cubed and put their constant only on this side. They would have put C1 minus C2 and just put it as C here and left the C off this side. It's totally up to you. Okay? Now, suppose we were to rearrange this. Can you see this is starting to look like this? If, for instance, we were to subtract y cubed from both sides and add x to both sides, then we're going to get this. We'll put the 5x squared term first. 5x squared, and then we'll subtract the y cubed from both sides. So you'd have minus y cubed equals, and we'll write down the 4y, and we'll add the x to both sides. So that'll give us 4y plus x. Okay? But then we'll subtract the constant c from both sides. So it'd have minus c. Now, you could leave it like this. A lot of people don't though. They prefer positive constants. So you could write this as 5x squared minus y cubed equals 4y plus x plus another constant a. A is the same as minus c. And I'd like to think that you can see that this is exactly the same format as we've got here. But you can see that we haven't got the 4 on the end. Well, this type of solution is called a general solution. I'll just write that there for you, a general solution. A general solution is where you have a constant in your answer. Because if you think about it, I could have written any constant here, and when I differentiated this with respect to x, I would have still got this stage here, because that constant would have differentiated out to 0. I'd have still got this equation here. So when I start to solve this, obviously I don't know what that constant's going to be. So a general solution then. But let's just suppose that we want to solve an equation which has plus 4 on the end. Then we're given what is called boundary conditions. And for this equation here, can you see that if I was to say that when x equals 1, y equals 0, it will actually satisfy this equation, because here we'll have 5 times 1 squared, that's 5, take away 0, which leaves us with 5 on the left hand side, and if y is 0, this term is 0, x is 1, so you've got 1 plus 4 is also 5. So x equals 1, y equals 0 satisfies this equation. So let's just write in here that we've got to solve this equation when x equals 1 and y equals 0. So carry on down to here. get our general solution. Now we need to work out what this constant of integration is, the value a. So we'll just move this over. Now, can you see that what we'll do is we'll substitute x equals 1, y equals 0 into this equation here. So if we say when x equals 1, y equals 0, and we'll number this, say 1, okay, we'll sub these values into 1, sub in 1, and what we have is that 5 multiplied by x squared, x being 1, so put that in as 1 squared, minus y cubed, y was 0, we'll just put the 0 there just to show that we did pass through that stage, equals 4 times y, y being 0, plus x, which is 1, plus that constant of integration a. And so we therefore have 5 equals 1 plus a. And obviously if we take away 1 from both sides, we end up with a equaling 4. So we can substitute this back into 1, okay, and so therefore our general solution turns into what is called a particular solution. We end up with 5x squared minus y cubed equals 4y plus x plus the constant a, which is now seen to be 4. So we have our particular solution. Let's just put that in there as the particular solution. Okay. And did this check out? Was this what we had earlier on? Well, yes, let's just bring back originally what we had. So was that constant on the end a 4? So if we slide that back over there, yes, you can see that that was a 4 up here. Okay, so let's just bring that back over to there, and that is essentially how we solve a differential equation of this type where we can separate the variables. We put all the y's on one side, all the x's on the other, and then integrate both sides. You should be able to, with practice, go from this line straight to this line. We tend to leave out this stage. We just go for one of these lines here. Normally say something along this kind of stage where you just have the one constant. You can use any letter you like, it doesn't matter, and you can place it in any position you like. So that gives us our general solution. Quite a lot of questions just stop at that point. If we're given values, we can get a particular solution where we work out our constant. And when you get your solution, you don't have to necessarily try and make y the subject. You can leave it in any particular form, unless you're asked to do that, okay? Asked to make y the subject. This is quite acceptable. Now, in other videos, I'll show you how we can work with other types of functions, especially ones that involve natural logs, because further work needs to be done on, or can be done, on simplifying equations like that. So I would definitely encourage you to have a look at some more videos on this, and you'll find plenty on my website, okay, in this series. And it's the best place to look for videos rather than on the YouTube channel, okay? It's got all of them in indexes, etc. Okay, so I hope this has been of some use just to get you started on solving differential equations.